So we're going to do our first example where we are really starting to compute these volumes. But before we get to that, let's talk real quick about Fubini's theorem, which has to do with the order of integration. If I do and integrate with respect to y first or x first. So Fubini's theorem says if R is defined by x is between a to b and y is bounded by functions of x where g1 and g2 are nice functions, so in particular they need to be continuous on my interval a to b, then the double integral over this region R would be equal to the integral from a to b, g1x, g2x, f of xy, dy dx. So you would first integrate with respect to y and then integrate with respect to x. Now, the second part is going to say if R is instead defined by C, y is between C and D, and x is now bounded between two functions of y, h1y and h2y, where h1 and h2 are continuous on the interval c to d, then this double integral over my region R is equal to the integral from c to d, the integral from h1y, h2y, f of xy, but now it would be dx dy. So you first integrate with respect to x and then with respect to y. So it all really comes down to how you describe your region. So let's, now that we know this, let's look at our example. So let's evaluate the integral of R 1 minus 1/2 x squared minus 1/2 y squared dA, where R is the region given by x is between 0 and 1 and y is between 0 and 1. So here, if I look at this region R, it's given by these conditions right here. What does that region look like? Well, think about this in the xy plane. X goes from 0 to 1 and so does y. So this region is a rectangle. So here, because the region is a rectangle, the order of integration doesn't matter here. You could either do dy dx or you could do dx dy. So I'm going to set up the integral 0 to 1, 0 to 1, 1 minus 1/2 x squared minus 1/2 y squared. Here I'll do dy dx. But you could just as easily do this as dx dy, and you'll get the same answer. So here we're going to compute this integral now. So start with the inside. You're going to integrate with respect to y. So notice these first two terms don't have a y in it, so they're constant. So you'll get a y there. And in the second term, or really this third term, I guess, you would integrate and it would be y cubed over 6 then. And now you're going to plug in 1 and 0 in place of y. So if I plug in 1, you're going to get 1 minus 1/2 x squared minus 1/6. If you plug in 0, you'll get 0 for everything. So now I'm going to simplify 1 minus 1/6. That's 5/6. And now integrate with respect to x. You'll get 5 over 6x minus 1/6 x cubed. Plug in 1. Top number minus bottom number. If you plug in 0, you'll get 0 for everything. So in the end, this is 4 over 6, or 2/3. And if you had computed this in the other order, if you had done dx dy, you should get the same answer, 2/3.